Okay, this is what we're gonna do today. I'm gonna teach you one thing, since the quiz took longer than expected. We're just gonna go over one homework problem, because period 6, I would say almost all of them didn't even do the homework. But not period 3, right? Eyes down. Okay, so this is today's lesson. This is actually almost the last thing that I'm going to have to teach you, right? Now, yesterday, did I or did I not tell you that this, like in physics, if you have the graph of the velocity, what does this area here represent?
Distance traveled.
Oh, so you guys are here for that? Yeah. Okay, so it's important to be able to compute the area between a graph, any graph, and the x-axis, not just line segments like you do in physics now, right? So this is how we do it. So let's start with a graph that's not a line. Let's start with a parabola. Y equals x squared. Just from 0 to 1. I want to compute the area between the graph and the x-axis exactly. I don't want an estimate, I want an exact number. This is how you do it. Okay, let me redraw this picture. That's too ugly for me. So, woo! It looks like the same thing. Y equal x squared from 0 to 1. No, it's a little different. Okay, so what we're going to do first is break it up into n equal parts. So from here to here is 1. If I divide it into n equal parts, then what is this? How do I label that hash mark? Oh gosh, okay. Okay, here's 0 to 1. That's 1 unit long. 1, 2, 3, 4, 5. Like in my picture, I divide it into 6 equal parts. Therefore, what is this? 1/6. Wouldn't that be 1/6? So if I divide it into n equal parts, then it's going to be 1 over n. And then what's this going to be? 2 over n, 3 over n, 4 over n, all the way until you hit n over n, which of course is 1, yeah? And then what we're going to do is we're going to form rectangles now. Now there's different ways you can make rectangles, but the way that we're going to do it is we're going to use the right endpoint to cap off the rectangle like this. So on this interval, you use the right endpoint and you make rectangles like this. We call these circumscribed rectangles because the rectangles are circumscribing the actual area that we're trying to find. Now, if I add up the area of these rectangles, is that exactly the area between the graph and the x-axis? No, that's an estimate, right? So, like in my picture, I have 6 rectangles. If I add them up, that's not the exact area. So, what if I want to be more accurate? What would I do? Huh? You make more rectangles. So instead of 6 rectangles, what about make 100 rectangles? But even if I were to add those 100 rectangles up, is that the exact area? No, so try to make more. What about 1,000 rectangles? 1 million, 1 billion, 1 trillion. Even if you made 1 trillion rectangles, is that exactly the area? No, it's close, but it's not exact. So what do you think we have to do to get exactly the area? Is you take the limit as the number of rectangles goes to infinity. So this is our strategy. We need to write a formula that represents the area of n rectangles. And then we're going to take the limit as n approaches infinity. Okay, so here we go. Let's start with the first rectangle. Now, can we agree that when you have a rectangle, the area is base times height? Because period 6, it took 1 minute just to figure that out. Okay, so what's the base of the first rectangle? What's that length?
Right minus left.
Yeah, which is 1 over n. And then how do I figure out the height? Well, isn't the height of the rectangle simply the y-coordinate of that point? Because the y-coordinate tells you how much you got to go up, right?
Yeah.
So if the x-coordinate is 1 over n, how do I figure out the y-coordinate of that point? You plug it into the function. So what is it? 1 over n squared. Okay, let's just leave it like that. We'll just worry about simplifying later. Second rectangle. What's the base? See, you guys are better than period 6. You know period 6 said 2 over n. No, 2 over n would be this. We were just talking about that. All of these are the same, right? They're all 1 over n. times the height. Now, isn't the height of the second rectangle simply the y-coordinate of that point? So 2 over n quantity squared. Rectangle number 3, what is the base? 1 over n. And the height is simply the y-coordinate of that point. You starting to see a pattern? No, these are just random numbers. And finally, when we hit the last rectangle, what is the base right there? 1 over n. And then the height is the y-coordinate of that point. N over n squared. Do not write 1 because then you're not going to see the pattern. And there you go. All I did is add up the area of n rectangles. That's it. Okay, but now we need to simplify this into a formula. Okay, first of all, what can I factor out?
1 over n.
You can factor out more than that. 1 over n cubed.
What?
No, when you square it, that's n squared. You square it, that's n squared, so n squared times n is n cubed. This is algebra. That's the problem. And then what's going to be left if I factor out 1 over n cubed? That's n, not h. 1 squared plus 2 squared plus 3 squared plus dot 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 plus n squared. And then in the parentheses, if you somebody. That's the stuff we're supposed to know on today's quiz.
I got that wrong.
So let's go up here. 1 over n cubed times, okay, I guess we don't need parentheses, times, what's the formula for 1 squared plus 2 squared plus 3 squared plus dot 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 plus n squared? n times plus 1. The quiz is over, Mr. Park. It's gone from my memory. 2n plus 1 over 6. See, so if you don't know the formula for this, you can't do it. You just can't do it. Okay, so this is the formula for the area of n rectangles. So if you have 6 rectangles like in my picture, to find the area, just plug in 6 for n. If you want to find the area of 100 rectangles, plug in 100 for n. If you want a formula for 1,000,000 rectangles, plug in 1,000,000 for n. But even, like I said, that doesn't tell you the exact area. What do we have to do to find the exact area? You take the limit as n approaches infinity. What if you had an infinite number of rectangles? Well, do we know how to compute limits? Yes. If the degree of the top is the same as the bottom, you look at the coefficients. Because look, if you multiply out the top, what's the first term going to be? 2n cubed. If you multiply out the bottom, that's 6n cubed. 2 over 6. 1/3. This area here then is exactly 1/3 square unit. This is not an approximation now. It's exactly 1/3 square unit. Whoa, Mr. Park, that's a lot of work just to get that. Yeah. But see, when you take calculus, then you're going to learn like some theorems where you don't have to do this. But this year in pre-calculus, you got to do this. Now, I believe tonight's homework is, instead of y equal x squared, it's going to be y equal x cubed. So I did this example for you. Do you think you can make the transition? What would be the only difference if that was y equal x cubed? Yeah, so these powers here would be cubes instead of squares, which means in the parentheses, you're going to have 1 cubed plus 2 cubed plus 3 cubed, and then you just got to use the other formula, right? Well, let's see if you guys can do it. Now, do you know your calculator can actually compute areas? Okay, take out your graphing calculator. Well, you only knew this when you were taking physics. Because that area represents the distance traveled, or the displacement. Okay, if you have a TI calculator, okay, we're not graphing now, we're just computing, yeah? So you gotta go to the home screen. Go Math 9. If you do Math 9, you should see this. This stands for numeric integral. Who doesn't see this? That means you have the newer version of the TI 84, yeah? Okay, then you see this. Okay, let me do this first, okay? Okay, so if you have an older version of the TI, then you punch in Math 9, what function do we want to find the area under? Y equal x squared, right? So you type in the function, the independent variable, and then from where to where do you want to compute the area? From 0 to 1. 0 to 1. Press the enter button, thing just spits out the answer. So since the answer was 1/3, you should be seeing 0.33333333. Okay, see you. Better watch the video then.
Yeah, I will.
Okay, now if you have the newer version, then see, this is how it's actually written when you take calculus. This is called an integral. Basically, an integral tells you the area under a graph, between the graph and the x-axis. So you need to type it in like this. This is the function. This is standard, that's the independent variable, and then from 0 to 1. So you just have to fill in these fields, and the thing will tell you the area. Now on the prism, the other class said it looked like this. You press the math button. Should I press the math button on the prism? And then you should have that integral thingy. And you look at the math button. Where's the math button? Oh, there it is. No. Well, there it is. The integral. Integral. And then just fill it in. Who else has a prism? You guys found it? Oh, so now you can find the area between any graph and the x-axis. Like, okay, what if I ask you to do this thing? Here's the graph of y equals sine x. And of course, this would be pi, yeah? Compute this area exactly. Well, take out your calculator and just do this. So the only difference is you change this to sine x, or you got to type it in like that. And instead of 0 to 1, you want it from 0 to pi. So change that to a pi. So if you're doing it this way, you would put sine x over here, and then 0 to pi, and then thing spits out the answer. I guess you wouldn't even need this other parentheses. Yeah, exactly 2 square units. The area under one arch of the sine curve is exactly 2 square units, exactly. Isn't that kind of amazing? What's a sine curve? Okay, so that's how we compute the area. But I can tell you, when you actually take calculus, you don't have to do this much work. You can actually just do it in your head after a while. Here, you want to test me? Here. Okay, give me a graph.
Y equals x squared.
Okay. From 0 to
And
10. Okay. Compute this area. Okay, silence! 333.33333 repeating. Try to do that on your calculator. Math 9. I hope I'm right. Yeah, I think I'm right. I'm pretty sure I'm right. 333.33333.
yeah.
Yeah, see, you can do it in your head. If I can do it in my head, you can do it in your head. Okay, last thing for today. Let's just do one homework problem and we're done. Because I think a lot of you got to catch up with period 6. Yeah? We're going to do problem 2A. Did you guys do 2A? Did you even look at last work? Okay, what you're supposed to do in problem 2A is write the power series for sine squared x. Now, I kind of told you guys how to do it yesterday, but who knows if you were listening. Isn't sine squared x the same thing as sine x times sine x? Okay, now, do we know the power series for sine x? Do we at least have some of them memorized yet? Oh gosh. And you got to memorize it to the end of the course because we're going to actually use it to the rest of the year. Okay, here, this is an easy way to memorize it. Sine is an odd function, so only going to have the odd powers. X minus x cubed over 3 factorial plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial. See, now it's going to be useful to know your factorial numbers. And then you just multiply it by itself. X minus x cubed over 3 factorial plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial. And then what do you think I'm going to do? You're going to multiply them. Now, how do you multiply polynomials? This is algebra 1. You take the first term, I think I told you guys how to do this yesterday. Distribute it. You take the second term, distribute. You take the third term, distribute. You take the fourth term, distribute. And you keep on doing that forever. Now, I'm nice though. If you look at the homework, don't I ask you to just write the first 3 terms only? Yeah, because believe me, if I were to ask you to just write 4 terms, all hell would break loose. That's what would happen. Okay, take the first term, distribute, go. X squared, so this times this, and then minus x to the 4th over 6 plus x to the 6th over 120. Now hopefully I don't have to do the other one because 5040, some of you have no prayer, yeah? Okay, take the second term, distribute it. Minus x to the 4th over. I'll give you a hint. A negative times a negative equals a positive. Plus x to the 6 over 36. And hopefully, I don't want to touch those. And then take this term, distribute. Over 120. Dot, dot, dot. And see, look, you have 3 terms already. You don't need to use this one. If I were to ask you to write 4 terms, then you gotta use this one. See, but I'm nice. We'll save that the rest for the calculus next year. And notice how I line up the like terms like I learned in 8th grade at King Intermediate. Okay, so that's 1x squared. What's negative 1/6 plus negative 1/6? Negative 1/3 x to the 4th. And this is where period 6 had trouble. Can you imagine the 4th line there with the 5040 like that? What's the least common denominator of 120 and 36? Quick. 360. 3 plus 10 plus 3, which is 16 over 360, which can be reduced down. Here, let me show you what period 6 did. Oh, divide by 2. 8 over 180. Oh, you can go some more. 4 over 90. Hey, you can go some more. 2 over 45. Is that the way you guys reduce? Just go by 2s every time. Okay? No, just do it. Boom! There you go, that's right. Did anybody attempt problem 2b? Who attempted it? You ought to mark your eyes down, huh? Just look away. Do not make eye contact. Okay, now when you have to do long division, see over here you're going to do long multiplication, then oh god. Okay, we're done already. The bell's going to ring in 2 minutes already. Hey, you guys need to catch up fast because this chapter is not easy, people. Yeah, series 3 is the homework, but who knows if you guys are going to get there. Some of you are digging a deep hole. The hole is getting deeper and deeper.